Hi everybody, I'm Erik, one of the co-founders of Lucidworks. And by day I'm a senior solutions architect helping out our customers solve problems. And one of the ways that, one of the things I see out there is that folks are making solutions more complex than they need to be. And by that, what I mean is they try to squeeze a whole lot out of a single, say, solar collection and do things like suggest and type ahead and those types of things out of a single solar collection, when one of the things that we can do to simplify, or at least make our lives easier, is to break the world down into smaller composable pieces of simple search. So what I'm going to do is go through some various use cases here of how we do this. So let me just go through the animations here. All right, we've got our Lucene query parser here. We drop the stop words, and of course search is mandatory here, and just is kind of optional. Okay, so I'm going to query for search. Right into the search box there. Okay, so inside the search box, right? What we would do is kind of think outside that search box and think about some of the ways that we can leverage the facilities that Solar gives us in kind of composable, synergistic, kind of maybe even emergent behaviors here by leveraging multiple requests to Solar and getting back pieces of information and leveraging pieces of information from, say, one collection and then factor that information into the request to another collection. And that can factor in various ways. Signals, for example. Signals in Fusion is just search. It's just two searches. It's a search to an aggregation collection to tell you back, for that particular query, what products or what documents have been clicked on the most. Take the information that we got back from that very simple search, right? We've logged clicks, we've rolled that up, we've got aggregations. We know for a particular query that these particular documents are the most popular. Very simple search, right? We just look for that keyword, we get back document IDs. We take those document IDs, and in that same search pipeline, we make a request to the main Solar collection, to our e-commerce products, for example. And we factor in the boosts. We make boosts out of the most clicked on products, right? So we've got two very simple searches that are happening here. One just to get popular things, and then we factor those popular things into another one, right? There's other ways that we can leverage that same type of facility in kind of a simplistic but working together way that makes the whole greater than the sum of the parts. We're doing this with a feature right now that's in development at Lucidworks called Rules. Same sort of thing as the signals. Been doing this with typeahead, and I'll show you how that works. And another one is location awareness, where we'll get to that. Okay, about me. Get through that, right? So, search is everywhere. We've got information coming in from all sorts of sources. At Lucidworks, one of the things we're doing is Solar is our hammer. We make a Solar collection for everything, right? For logs, for log aggregations, for signals, for logs, signals aggregations, and now rules, right? So we have these Sidecar collections that have related information that we're piecing together. Right. So let's just go through kind of the anatomy of the search results. And what I want to kind of emphasize here is that, and this is probably things that you already know about Solar, but I want to kind of emphasize the basics of what Solar gives you. Right? So kind of typical looking search results here. The data that you see here are talks that were given at a an event called Search Camp at the United Nations in New York this summer. So I gave that presentation there, and I'm just kind of reusing the screenshots here for that. Okay, so typical search results, facets, and so on. Let me just highlight the pieces there, right? We've got relevancy ranked results, facets, we have highlighting, we have grouping. All of those features Solr gives you out of the box, right? Let's leverage those features to put them together in interesting ways, right? So, for example, well, we'll get to that in a second. So, again, relevancy, ranked results, fasting, highlighting, grouping, more like this. And did you mean spell checking features? Let's talk about typeahead, also known as autocomplete, suggest, instant search, those types of things. Solr offers a suggester. What the suggester returns to you is a string. What I'm proposing is that we want to return things, not strings, right? We want to have more information about our suggestions than just the string that maybe has our what we've typed highlighted. We need more information. Let me give you some examples here. Okay, this is for a project that I did with the NYU Langone Medical Center for their typeahead suggest. The UI that you see here is our prototype UI. They built it back into this. So this is the end result of what you see there. Let me point out, so we've got grouping going on in our suggest. So as we type, our results are grouped. Can't do that out of the box with just the Solr suggest feature, right? But Solr offers that capability. How did we do that? We built a separate typeahead collection. Sounds simplistic? That's kind of the point. It's just search, right? I have my typeahead index that is indexed cleverly with n-grams, perhaps phonetic, stemming, those types of fuzzy things in there. And I simply take what the user typed and ask the typeahead collection to give me back some results. And so I get did you mean in the suggest as well. I get grouping, and I get highlighting, all of those features because I took, instead of the main collection, which in this case is providers, the entire application is to find a doctor or a provider, and broke it down into, and created another collection, a typeahead collection, that had the various entities that the domain is using there. So there's providers, of course, that's the main collection, but there's conditions, and there's specialties, and there's actually languages too. You want to find a doctor that speaks your language. And because we have those entities tagged, basically, or labeled as, again, as a provider or a condition, a specialty, or a language, that when I make that request to that typeahead collection, I can get back and group the results based on that type of entity that's in that collection. And again, I can provide additional features like did you mean, the spell checking facility there, right? So the point is that we've used just search. We've just made something very simple here, just a sidecar collection, instead of trying to maybe contort or bend our main provider collection. The whole idea, again, is to return providers that offer, that service a particular condition or have a particular specialty. So the user can type in a specialty name, right? And in the main provider collection, that is simply a field, right? And language is a field, and condition is a field on a provider. But again, we've made a sidecar collection that gives us just what we need for the typeahead. It's just search. All right, okay, I'm going to call out the various features there. And here's that same sort of facility with that data that I put in for the presentation this summer there, right? So these are the talk titles that were given at that particular event. And I built this kind of proof of concept or prototype UI there that gave me back let me explore and Ajax actions as I'm typing. So one of the things, again, we'll suggest things, not strings, right? These things, these entities have additional metadata to them. And in a way, this is kind of poor man's entity detection or a suggest, right? So these are entities that are in there. Again, they're just, nothing complicated there. They're just ingrammed so that you can, get starts with type things. I built it so that it could, do partial in-string, so not edge ingrams, but also ingrams, also phonetic and stemmed and all those types of things. And the customer could tune which fields, how they wanted that experience to work by just leveraging out-of-the-box Solr facilities such as edis max and spreading the query across those basic fields there. Right? Just search. The type ahead request looks like this, right? If I type in the word search, or I'm starting to type in the word search, I just do q equals what the user typed. And I get all of that stuff back. Simplistic, right? But again, many applications I've seen with type ahead, they try to use the Solr suggester, and oftentimes it's just not robust enough. And it's not that there's anything wrong with the Solr suggester, it's just that it's kind of a search intra-index that doesn't give me back the full experience of what I get if I use a full collection to do that job. Make sense? Let's talk about signals. Signals in our terminology here means any kind of event that we want to feed back into the system. The most common types of things that we talk about are clicks, add to carts, purchases, user history, behavior, preferences, that sort of thing, geolocation. Those types of things can be events that we want to push back into the system and leverage those to enhance the search experience against our main data collection. Here's a screenshot from Fusion that allows a side-by-side comparison of two pipelines. One pipeline includes signals and one doesn't. And what I did for this particular example was just give Steve a little bit of a boost there, and I faked a signal for his event, for his talk. All right, so now it comes up higher when I search for search. Works like this, right? I've got main search results. Someone clicks on it. Those clicks get logged, raw clicks get logged every time into a separate Sidecar Solr collection, our signals collection. And the gear spins in a background job that aggregates up the raw clicks, creates what we call an aggregation of signals. So we roll up all of the query terms and the documents that were clicked on them and give them a weight based on the number of clicks that occurred. And in our main search pipeline, we simply make a request to that Sidecar aggregation collection and say, someone just searched for search, what are the documents that have been clicked on? Give me that back. Now, what you see at the bottom right there are three stages. The first one is a subquery to, it's just a Solr/select to the aggregations collection. We get those aggregations back. We can roll those up. So we may we may ask for, say, 100 results back from the aggregations index. Now we curate that inside of the pipeline with the next stage, the roll-up stage, and kind of pick out the best ones from there. And then the next stage fabricates the parameters that we're going to add to the main collections request. So the boosting query or boosting functions that we're going to pass off to the main Solr collection. Again, very straightforward, just search. We're just making a search. So we make a search to our main collection. Again, makes the request to the aggregations collection using the same query that the user typed. We can tailor that against the aggregations thing with QF, PF, and so on, so that we can spread that across multiple fields and sort the results and all that sort of thing on that sub-collection. And at the end of that, it just ends up being a boosting query to the main collection. Simple as that. What you see on the right here is a Solr response, but coming from Fusion. So we just add an additional node in that Solr response. Nothing that would affect any Solr clients at all, but it allows us to stuff additional information into the Solr response, such as in this case, just for diagnostic purposes, I push the entire aggregation subquery results into the response. So in this case, I'm actually getting 2 Solr results in one response to the query. I'm getting the main results, but in this extra section that we add into the Solr data structure there that comes back, we put in the full Solr response. So you can see response, num found, that's just a Solr response, but it's nested inside of another Solr response. So that in and of itself could be a very powerful mechanism where I could make a simple request to, say, Fusion, and now get back results from rules, from signals, and so on, and bring all of those things back into one cohesive response. So let me tell you about our rules implementation that we've been building. So the idea with rules is to have some kind of context-sensitive steps that we want to take for processing in that query request pipeline. So what happens is business users, let's just kind of talk about the e-commerce case because that's where we've developed this. It's not specifically for e-commerce, as you'll see. But in e-commerce, it's very common, it's a big need to be able to allow business folks to control some special promotions. You want to have something that boosts a particular brand that you have a special deal with based on certain keywords and so on. Something that you're not going to be able to machine learn in any way. This is totally a business level kind of decision to say, if I search for hammer, I want this particular brand of hammer to come up higher, right, to boost that thing. So what we have developed is a Sidecar rules collection, just a simple Solr collection. It only has a handful of fields there for query, filters, date, time, and tags, and so on. And so you can create a rule with a trigger. So for a particular keyword, I want this action to happen. For a user that navigates to a particular category on my system, I want to control what facets are shown. Maybe I want to provide a redirect. So for a particular keyword, right, your e-commerce site has products in its main collection, but folks type customer service or help, right? You don't have any products that have that in the descriptions of your products, but you want the user to make it to your FAQ or your customer service page, right? Certainly you can catch that at your application tier before you even pass that off to the search engine. But now you're going to have to implement fuzzy matching, right? If somebody types in service or customer service or help or FAQ, like you're going to need to build your own synonyms and all this sort of stuff, right? So let's just leverage plain old search to accomplish that. So what we do is in the pipeline, when the request comes in, we make a request to the Sidecar rules collection with the query context. We pass over the user's query, we pass over the FQs or the filters that that's been passed in. We pass in now, so we get the current timestamp of that request and pass that in, because you might have rules that only apply in a particular time window. Maybe you have a product that is getting released tomorrow, and you want to block. It's in your collection, but you want to block it until tomorrow, right? You're going to make a big release, an announcement. So you can make a rule that says tomorrow, or now we're going to block that product, and then tomorrow the rule isn't in effect. So we'll have a block rule that's in effect until tonight, right? So that's the idea. We also have the concept of tags in there. So you may have rules that you want to test out before you push them into production. So I added the concept of tags. Again, very simple. Tagging things is an age-old kind of technique here, but we just simply give it tags. Tags could be production, test, QA, so that I could create a rule, test it out in my simulation environment, see how it behaves, and now promote that rule when I'm satisfied with that it's working properly to production. And you have the same rules collection that can service your staging or your test environment as well as your production environment, right? So your rules are all common, and then you let business users control whether rules are visible in production or not. Another use that we have actually in not quite production, but in pre-production with a very large e-commerce client is to tailor the search experience whether a user is coming from a desktop device or from a mobile device. So if someone searches for mobile phone from a desktop device, they will get different results or different boosts from that device than if they were searching from their mobile phone. Maybe you know what kind of mobile phone is, so you can say, boost things that if they're coming from an iPhone, that you're going to boost things that are, specific to Apple products, right? So you can do those sorts of things with this rules facility here. Rules, as it is implemented, as it is, it's really kind of a superset of the signals. So in our rules implementation, we actually could potentially aggregate, auto-generate or aggregate our raw clicks into the rules collection instead of the rules aggregation collection and just leverage the rules facility for that. So it's similar kind of facility. We've developed, and this, it's a work in progress right now, but we have a basic rules editor. Just search results with facets and, results there with a search box. It's just another Solr collection. Nothing special about it. At query time, we have the same sort of facility here where we make a Sidecar collection. We make that subquery to the Sidecar rules collection. Well, that first stage, actually, the prepare subquery, that's where it's a JavaScript stage at the moment where we get the current date time, we get the FQs that are coming in from the request, and we peel those off so that we can then add that to the rules collection subquery. And that's what that retrieve effective is. It's just a subquery. Again, just a /select to the rules collection. And then there's a stage that takes the rules that were returned, the context-sensitive rules for this particular request, and processes them. So for a block rule, we would just add an FQ minus ID, something that's going to get released tomorrow. So I'm going to block it today, but it just minuses it off. It's a very simple effect on the main Solr request. And what you see on the left there is what the response looks like from the Sidecar collection. Just a Solr response there, but you can see that we get back banner here, and we get back a redirect. So we've got some basic rules here just for this demo purpose, right? So if someone, what this says is the first rule that you see, the first document that you see there is a banner rule, and it says welcome to Search Camp. I should have actually tailored this and said, welcome to Lucene Revolution. But that's the idea here, is that we've just had a banner rule. There's no triggers on that particular rule. So every request that comes in gets that banner. And by banner, all this means is that it's a response value. What that means is we put that back into the Solr response. Not in the main Solr response that you already know and love, but in an additional node that's in there. And likewise, with the second document that you see there, it's a redirect rule. That redirect rule says if the user's coming from a desktop device in production, so I've tagged it two different ways here, then, and they've searched for Solr, then we give them a redirect to the main Solr website. What this does here, this also just puts it in the response. It's up to the client to actually do the redirect if that's what you want to happen, or put it as see also is kind of how I do it with these redirects, right? So the search UI will say, see also the Solr website. Okay, and here it is broken down in the main search here, right? Again, somebody searches for Solr search. The requesting application says what tags you want. It says that this is a production request. You could bake that production tag into, say, the Fusion query pipeline in that case, so the client's not necessarily specifying that, but you pass in the tags that you want, so what subset of rules should be possible to trigger. Pass the main query. I can turn rules on and off as well, so we have an enabled flag, so we simply only allow rules that are enabled or not disabled, I guess is the logic that's being used here. We take the now, the current time, and FQ for only rules that are effective at this point in time. That now is something that we can simulate as well. So in our simulation UI, you can say when now is, so that I can pretend like it's Valentine's Day, create a rule that says boost chocolate on Valentine's Day. I can test it out. I can see that if it were February 14th, that rule would be in effect. Okay? And then we, FQ to the tags that were specified, right? So again, very simple search mechanism here to give me back the rules that are in effect. I could have thousands. In fact, both of our customers that we've been working with the rules so far have thousands of rules. They literally have thousands of rules. But in a single query request, only one or two rules are going to fire, right? It's not onerous in that respect, all right? Because they're keyed off of the keywords in the request or the filters that are there and so on. Or they're test ones that aren't in production. And then we simply take the results that we got back from that sidecar request and then run it through some script and says, okay, this is a banner rule, add that to the response. It's a redirect rule, add that to the response. It's a set params rule, set Solr params rule. Now I'm going to set some Solr parameters. And those are the basic types of rules that we have, is a response value and a set params. We have kind of bubbled up some higher level abstractions that make it simpler to do things like in our rules editor UI, when they click add rule, there are some higher level abstractions that say this is a boost rule or a block rule, and it lets you put in an ID and that sort of thing. But ultimately, in the processing, it's just setting Solr params. And looks like that. And again, we take that sidecar request and stuff it into the main Solr response there that we get back. Geo Lookup. Now this isn't quite so this is actually a very similar type of mechanism here. So in that NYU Langone Medical Center find a doctor feature, the user can put in their zip code. And when they put their zip code in, what it does, we actually have a separate index that is zip code to lat longs, effectively. So we make a request to the zip codes collection, pass the zip code, get back the lat long, and then augment the main Solr request with the geo filtering, right? Straightforward. Now, of course, we're making a separate Solr request. Is that performant? I mean, this is cached, right? So how many zip codes are there in the New York area? You know, after a few minutes, all of the zip codes have been cached, so it's, you know, a millisecond or so to get that response back. So there's no performance concerns when it comes to that sort of thing. And it looks like this in production. So you can go to the site now and see this sort of thing. Okay, so got 10 minutes. Kind of wind this down. I've got some demos so I can show that. But kind of just wanted to show you that the whole can be greater than the sum of the parts. I can make these very simple search requests. There's actually a little bit of more magic down below, right? We've got our oregano and our null and our and so on. It's got awk on there, right? Everybody remember awk? So we can blend these simple things together and get something much more rich than we would have otherwise. That's the idea, right? Simple things working together, wholes greater than the sum of the parts, emergent behavior perhaps, just kind of some interesting things that I think about there. Like clicks for themselves, right? That's a total feedback loop, right? We're bringing things in, we're boosting things, and that's, of course, going to affect what the user sees and what they're able to click on the next time around, right? So things are the search results are changing right before their eyes, and it's learning as it goes, right? And it's, you know, turtles stacked on each other. There are some resources there. In my GitHub, there's a search camp directory. It's a full-fledged example of what I'll run the demo here in a moment and show you. That's a picture from Banana, our dashboard there, and those were the tag cloud of the words that were in the talks there. So I thought that was kind of interesting. That just kind of said, open discussion, welcome. So, right. So Fusion fuses these things together, right? The query pipeline in Fusion allows those simple things to be put together and give you this rich response. Any questions as I hop over to the demos? Yes, sir.
You talked about rules and signals.
Yeah.
When client is making a call, they will be using only query pipeline. And your query pipeline looks like you're going to make a call to rule collection. Also, you're going to make a call to signal collection.
That's correct.
Let's say there's a rule called search redirect rule. When somebody is doing a particular query, I'm going to redirect the user. How can we control bypassing all other collections whenever there's a search redirect rule? Can we do this kind of bypassing the query stages in the query pipeline?
Sure. So are you using Fusion?
Yeah.
Okay, so is the question, okay, thank you for asking. I'll repeat the question. So could a rule affect the processing of the rest of the query request? Could I have a rule that said bypass these additional stages? And the answer is yes. I haven't built any of those types of things in there, but the rule processing is right now just a simple case statement in JavaScript that says, you know, for a redirect rule, add this to the response. For a banner rule, add it to the response. For set params, control the Solr params. I could set some other context variable in that pipeline, and then another stage could conditional off of that and say, skip it if that rule fired.
Yeah, but okay.
Yeah.
But it means that, let's say I have a banner rule, I have a search redirect rule, n number of rules.
Sure.
That needs to happen, the bypassing needs to happen only when one particular type of rule is triggered. So we will end up having multiple query pipelines, and in each of the query pipeline, we need to configure all the JavaScript logic.
Sure.
So it means the client has to call multiple query pipelines?
No. It's all in one query pipeline. In fact, I'll show you right here with this stuff right here. So this search camp collection right here, if we look at the query pipeline for the search camp demo here, you actually see a lot of stages in there. Some of them are kind of diagnostic for debugging there, but here's our aggregation. So we've got signals in there. Here's the rules subquery right here. So it's got all the FQs and tags and all that kind of stuff there. So it's a very simple Solr, well, maybe not as simple, but we make just a /select to the rules collection. And then here's the process stage. Might look a little hairy here, but it's just a JavaScript here. So we say, if it's a set params, then I simply put the params or add a param. Parameters can be an append or a replace. If it's a boost rule, then we add the boost, right? So we can boost by that. If we, right, and so I can easily add another rule in here and create a type of rule, and then say, set something in the context, and then later processing stages could do something with that. What's that? When are we going to release this feature? Well, I'm an open source guy. I probably put this stuff out there without permission per se, but this is actually the Fusion pipeline here for the demo. So this is actually where all that rules processing is here in the pipeline and the signal. So that one pipeline definition right here is all of what you see here, right? So it's open in that that's there. I did not put the rules editor there, but the rules themselves are just Solr documents, right? So it's kind of straightforward here. Here's a CSV file of the rules, right? This is the banner and the redirect rules that I just showed. And this is just Solr documents, that's all, right? So all of that stuff is basically there. The rules editor looks like this, right? So here are those two same rules that are there. I can, let's see if I can make this thing work. This is actively in development here. This should turn it on and off. There it goes. Turns green or not, right? I can, and forgive a little bit of crudeness here, but I can come over here and say, this rule is only effective in prod, right? And now save that rule. And now that rule's only gonna, and I didn't really show that there. It should show the trigger there. So a little bit of work in progress there, but we can tag a rule. We can bulk action, so I can come over here and say, I want to disable all those rules that I selected. I want to tag them all in bulk and that sort of thing. So this is, and we have a simulation UI over here. It's hard to see, but there's the banner. This is our Lucidworks view UI here, but this is showing that the banner worked. Some other things I can show real quick is the compare mode. So I can put this in, show the default pipeline here, show the demo pipeline here, and without even giving a query, the signal's already kicked in and boosted this one up, right? So if you look at the data over here in this one, I've got some fake clicks, and I fake clicked up doc ID 7. That's it. That's a Fusion click right there. And so that's what made this one show up. This one is ID 7, right? So now I can have, let's see, if I say Solr, right here, you can see that we see the landing page right there of the rule that triggers off of that search right there. And our search UI right here, if I search for Solr, oops, and that's telling me we're out of time here. But we see the, the banner and the redirect because I searched for that. Right. Any other questions? Here's the typeahead stuff that I've been doing. All right, so you can see that kind of thing. And we have another kind of simulation UI here that shows the banners maybe a little bit more attractively here. I can search for Solr here, type, and I can see the landing page, which came in from both of those came in from the rules. And you can actually see the full rules response. Actually, see it right here, right? So everything that you see minus that fusion element there is a plain old solar response. This fusion node right here contains the output of the rules as well as the actual solar responses from those Sidecar collection queries. It's just a straight up request to Solar. I did edge engrams. Yep. That's right. So the lat long is, it provides a lat long, which is, I guess, the center point, and we just say, 10 kilometers around that. Yeah. Yeah. You're trying to find a doctor. You're not so concerned about the jagged edges of the zip code, right? Yeah. Thanks, everybody.